So we're going to look at an example here, and this is just review. Actually, it's not an example, this is just review. If you remember, so this, do not confuse concavity with extreme values, okay? Extreme values are the high and the low point, true? So this here is an extreme value. This here is an extreme value, okay? So this is where f prime is 0. This is also where f prime is 0, okay? Now, if we remember from last year, the point of inflection is where? It's like in between. It's like it's where the concavity changes, right? So do we agree this part is concave up here? Yeah? Yeah. Concave up. And then after that, it starts to kind of look, this part here, it's concave down, right? So the point between where this changes here, this is what we call the point of inflection. And if you remember last year, remember how we couldn't quite find it? Or I just told you to like approximate it, right? So now we're going to find it exactly every time. Okay? So here, for this whole interval here, this f double prime is less than 0. Okay? For this entire interval here, f double prime is greater than 0. And connecting it to prior knowledge, here it's increasing. So here f prime is greater than 0. Here it's decreasing. So here f prime is less than 0. Are we okay so far? This is where people get confused when we throw everything together. If you get confused initially, don't worry. Okay? And then here it's increasing again, so f prime is greater than 0. Okay? So this is, again, just connecting those ideas to what we've been working with. Okay? So now we're going to apply the second derivative test, and we're going to do an example of this here. Okay? This is just a review so far. So example 1, second derivative test. So what I want you to do is I want you to find the intervals of concavity for our function here, f of x, and let's just go ahead and let's make one up. We'll start something with something very simple, okay? So I'm going to give you a function I would have given you last year. And we're gonna do this algebraically. Last year we did it graphically. You would just drew, with the picture. Now we have the power to do it algebraically now. It's gonna be really simple, okay? So we're gonna find the intervals of concavity for this function here. And we're gonna do this in steps. And step 1 is we wanna find the points of inflection. The points of inflection. So how do I find the points of inflection? Step 1, you just find where f double prime is 0. Right? So what do I have to do? Take the derivative how many times? Twice. There's at least 2 questions on every AP test where it just asks you find the point of inflection. Okay? So we have to say, so I have to take the derivative how many times? Twice. So I'm going to say, so first find f prime of x. Look, do it slowly. F prime is what? 3x squared plus 2. True? What is f double prime? 6x. Now I set it equal to what? And solve for x. We are going to now, when you do this, after you set it to 0, Jelani, you're going to solve for x here. Okay? So then, if I solve this for x, I divide by 6. What does this give me over here, Daniela? X is 0. So now notice, this gives me here, this is my, remember we thought of these as my barrier, okay? And now we're going to do the same thing as we did with the first derivative test over here, okay? So basically what you're going to do is you are going to draw a barrier here, and then what's my only mark here? Where's my only point of inflection? 0 here, okay? And we're going to say, okay, cool, so I'm going to test around here, and when you test it, where are you going to test it into? What test is this? So when you test it, you're going to test it into what? Second derivative. So just to clarify, I'm going to write down the second derivative. F double prime of x is just 6x, right? All right, and we know this was my critical number here, so we're going to test into here. What's up? Oh, absolutely. Is that cool? Okay. So we're going to pick points. Somebody give me a number here. -1, who cares? How about here? 10. Doesn't matter. Okay? You pick anything you want. You don't have to pick easy numbers. I like 10 because you can, remember, you're just looking for the sign. You're not looking for any kind of quick calc or any kind of anything fancy. So if we plug f double prime of -1, what do I get? Is it positive or negative? It's negative. So this means it's concave what? I'm just going to write C, D. Is that cool? Concave down. And then what about here? What is f double prime of 10? 60. It's 60. What is 60? Positive or negative? So this is up. So then, so I'm going to write my intervals of concavity now. So I'm going to say, so it's concave down from where? Tell me over here, Annabelle. Negative infinity to 0, and it's parentheses. Why? Because at 0, the second derivative was what? It was 0. Remember, before 0 it's negative, after 0 it's positive, and then Rodrigo, where is it concave up? Yeah, 0 to infinity. And this is how you use your second derivative test here. Very similar to the first one.